Okay, mode of action of herbicides. Under that, what is the mode of action of herbicides? Okay, translocation and the absorption. These are the mode of action of herbicides. The mode of action refers to the entire sequence of events from introduction of the herbicides into the environment and to the death of the plant. The following terms are concerned with the how herbicides kill the plant. Okay, see the herbicide. What is meant by the herbicides? Okay, a chemical that kills or inhibits the growth of plant is known as the herbicides. Contact herbicides. Herbicides that causes injury only to tissue to which it is applied. Mobile herbicide. A herbicide that moves or translocates in a plant. Then simplest. The total living protoplasmic continuum of a plant. It is continuous throughout the plant and there are no slag of living cells. The phloem is the component of the symplast and the long distance symplastic transport via the phloem. Apoplast, the total non-living cell wall continuum of a plant. The xylem is the component of the apoplast and the long distance apoplastic translocation is via the xylem. Then burn down refers to applying a foliage active herbicides before planting to kill the undesired vegetation. Then pre-plant incorporated refers to applying a herbicide to the soil before planting the crop and then mixing with the soil. Pre-plant. When it is applied, pre-plant, name itself indicate the herbicide is to be applied to the soil surface before planting the crop. Pre-emergence. It is also applying the herbicides after planting but before the crops or weeds are emerged. Then directed refers to applying the herbicides. So contact with the crop is minimized. Then post-emergence refers to the applying herbicides after emergence of the weeds to the crop, including broadcast or the spot treatment. Are you getting? These are the some terms of the herbicides. Mode of action, under that what happens, how the action of herbicide is there. First is the absorption. Absorption of applied herbicides occurs to the shoots or root tissues. To be effective in killing the weeds, see, the herbicides applied post-emergence must move through the leaf surface to the living parts of the plant cell. Then, although the leaves are the most important absorption site, absorption can occur any above the ground plant part where the herbicide is present. After pre-emergence application, the absorption is primary through the root tissues, but can also occur through the shoot tissues in contact with the treated soils. As with the post-emergence applications, herbicides applied pre-emergence must absorb into the plant and move to the symplasm for the activity. Then, root absorption can important after a post-emergence herbicide is application. When the herbicide reaches to the soil and moves in the soil to the root zone. This is the absorption of herbicide mode of action by the shoot and the root tissues. Absorption by the leaves and the stem. There are so many factors which affect the absorption by influencing the amount and the distribution of herbicides on the plant surface. What are that factors? The surface tension of the spray solution, then inherent wettability of the leaf surface, what is the condition of that cuticular wax or physical structure of the wax, then what is the leaf hair surface hairiness condition, then what is the leaf orientation condition, then total leaf area per plant. All these factors affect the absorption of herbicides by the leaves. Most of the herbicide applications are made with water as a carrier. Water has a very high surface tension due to the hydrogen bonding between the water molecules. Thus, a water-based spray solution has difficulty in wetting the wax surface of the weeds. The surface tension of water can easily be reduced by the addition of the surfactants. In that condition, when we use the water as a carrier into the herbicides, there is a due to the surface tension of water, we have to add the some surfactants. Okay, the type of surface wax which is present on the leaf surface is also affect the your herbicide spray solution. Okay, that is if it is effect the weight the leaf surface or penetration into the plant. It depends on the epicuticular wax condition. Leaf surfaces covered with the crystalline epicuticular wax are much more difficult to wet. There are different types of the waxes according to the leaf species. The retention of the spray solution on difficult to wet the leaf surface increases with smaller droplet size, and as the surface tension of the droplet at the moment of impact decreases. Large difference in the absorption between the species in some cases can account for the herbicide selectivity between the weed and the crop. In some condition, herbicide selectivity is also necessary. The most commonly example of this is that onion and the brassica species such as cabbage, because they absorb a minimal amount of herbicide as a result of their thick leaf cuticle. Once herbicide has contacted with the plant surface, five things has to happen. Which are that? First, herbicides are volatilized and lost into the atmosphere or washed off by the rain. Then remain on outer surface in the viscous liquid or crystalline form. They do not reaches up to the all plant part. Then penetrate the cuticle. Okay, but remains absorbed in the wax component of the cuticle. In that condition, there is a no use of herbicides. Then penetrate the cuticle and enters the cell wall, and then translocate prior to entering the symplasm. This is called as the apoplastic translocation, which includes the movement in the xylem. And next is the penetrate the cuticle and enters the cell wall, then moves into the internal cellular system for symplastic translocation, which includes the phloem movement. Already we learned this apoplast, symplast. Okay. This is about the absorption. Under that, root absorption of herbicides from the soil is also the mode of action. With the exception of the gaseous fumigants like methyl bromide, see, herbicide affect the plant failed only after germination begins. Thus, the entry of herbicides into the ungerminated seeds during the water imbibition may occur, but it is not considered important to ultimate death of the plant. Okay, we require the death of the plant. Importance is the absorption of herbicides into the root as they begins to grow out from the seed. See, the absorption of herbicides by the root is not as limited as absorption into the leaves. There is some limitations in the leaves. Already we learned leaves absorption, but here there is no limitation. The primary reason for this is that there is no significant wax layer or any cuticle is present at the root locations. Okay, where the most of herbicides absorption occur. That's why the most important pathway of entry is the immigration of herbicides with water being taken into the plant in the root hair zone, okay, of the root tips. Root hairs are the very important part of the present in the root, increases surface area of the roots and available for the uptake of water and the herbicides. There is no any specialized way of entry for the herbicides into the root tissue. They can go along with the mass flow of water because they are dissolved in water. Even though the water solubility of some herbicides absorbed into the root is low, the solubility is adequate to deliver the needed dose to the site of the action. Okay, there is no any matter the water solubility of some herbicides, because we at least adequate dose is necessary to need up to the root of that weed and the weed get killed. Herbicides in the vapor phase in the soil may be important, but it will still have to diffuse through the film of water surrounding the root tissue at the root tip. Next is the shoot absorption of herbicides from the soil. See, what is that shoot absorption? Shoot absorption is an important means of entry for many soil applied herbicides that are active on germinating seeds, varied or small seedlings. Before emergence, a shoot has a poorly developed cuticle and probably no wax layer, making it more easily penetration by these parts herbicides. In addition, Casparian strip barrier is not present in the shoot tissues. Hence, the shoot absorption is a particularly important route of herbicide entry in the grass species, but less so far in dicot weeds. The shoot zone entry is by the diffusion from the herbicide dissolved in the soil solution in contact with the shoot tissue, or probably more important, diffusion from the herbicide present in the vapor phase of the soil. Are you getting? The herbicides known to have the major route of entry in the shoot zone are primarily growth inhibitors, having their site of action in the shoot meristem as it emerges through the soil. This is about the shoot absorption. Then absorption across the plant membranes. All biochemical target sites for the herbicide action are located within the living cells. For the herbicides to reach their target sites, they must cross the membrane which is located at the cell wall, which is known as the plasma membrane. Every cell wall having the plasma membrane, and if anybody want to cross the reaches up to the cytoplasm, then they have crossed through the plasma membrane cell wall. This is the basic things. Okay. There is also additional organelle membranes like chloroplast envelope is there. Most of the herbicides process this membrane by the simple diffusion only, although a few have been shown to move with the help of specific carriers. Some herbicide need the specific carriers. In these cases of herbicide crossing the plant membrane by the simple diffusion, movement is related to the concentration gradient across the membrane, that is higher concentration to lower concentration. The herbicides moves from a region of higher concentration to lower concentration. When the concentration is equal on both the sides of the membrane, then at that time accumulation stops. Hence, we require the concentration gradient condition. The herbicide concentration gradient across the membrane is the driving force that moves the herbicide across the membrane. Are you getting this point? The second important parameter for the diffusion is the partition coefficient of the herbicide with the membrane, which represent its ability to dissolve in the membrane. This is partition coefficient, that is the ability to dissolve. Lipophilic herbicides are able to move more freely across the membrane than the hydrophilic, that are water soluble herbicides. See, some herbicides can move across the plasma membrane against the concentration gradient. These herbicides have an ionizable group. Carboxylic acidic group is present in the herbicides. This is about the absorption condition mode of action across the plant membrane. All this is about the absorption. Next mode of action is the translocation. See, once a herbicide has penetrated in the leaf or the stem cuticle or the root epidermis, there are still many barriers that can affect the movement of its site of action. Translocation is very important after absorption. The herbicides can move into the portion of cell not containing the site of action, resulting in the herbicides become compartmentalized and no longer available for the transfer to its site of action. That's why the translocation is very matter to kill the weed. The number of herbicides are conjugated, that is chemically bound and absorbed onto the cellular component or in some way inactivated in the plant roots or the leaves and do not move to the other part of the plant. The number of selectivity mechanisms that differ between the weed and the crops are the result of differential compartmentalization or inactivation by the metabolism. See, next is the short distance herbicides movement across the few cell layers occurs by the simple diffusion, ion trapping, or for a few herbicides carrier-mediated processes. Some herbicides require only diffusion process to reach their target site of action. Assuming that the herbicide is not immobilized in some manner, it is available for the long distance movement in the plant through the xylem and the phloem transport system. In both the system, herbicide dissolves in the water and may move along with the mass flow of water. Hence, xylem and phloem is also helps in translocation process. Herbicides that enters the plant root may move upward in the xylem with the flow of water. The majority of pre-emergence herbicides transported in the xylem system then enter the root near the root hair zone. This is because these herbicides molecule get dissolved in water, and that's why it is possible to get the mass flow with water. Thereby, they reaches to the root zone or by the root hair root and kill the weed. Phloem. Movement of herbicides in the phloem follows the same path as by the product of sugar. Translocation in the phloem system is from the source to sink. Okay, examples of the sinks are roots, underground storage organs, young developing leaves, all meristematic zones, flowers, and the developing and the fruits. This is the translocation process. Next is the general mode of action of herbicides. Under that, photosynthetic poisons. In that, first is the interfere with the Hill's reaction. In photolysis of water, here is evolution of oxygen, which is interfered by the herbicides like triazines, carbamates, urea derivatives. Then interference will lead to no supply of oxygen. Some interference in electron transport chain. Herbicides like paraquat, diquat, bipyrrolidine after several stages. Those interfere with the cellular metabolisms. These are 2,4-D, phenoxyacid, benzoic acid series results into an controlled growth leading to the collapse of xylem, phloem and the plant get die. Interference in the protein metabolism. Herbicides like butachlor interfere in the protein metabolism, resulting in the stunted root growth, thereby shortening of stem and plant may die. Uncoupling of oxidative phosphorylation. Herbicides like DNOC, MSMA, even arsenic-containing herbicides enter in the oxidative phosphorylation process, and there is no formation of ATP. Plant does not emerge and it's die. Are you getting? This is the general mode of action of herbicides. By this way also we can kill the weed. Next part of the herbicide is the persistence and the fate of herbicides and the residual effect of herbicide. Persistence of herbicide, that is how much long period of time herbicide stays in the soil. The length of time that herbicides remains active or persist in the soil is extremely important. The herbicide residues are important as they relate to the phytotoxic carriers that may prove injurious to the subsequent crops or the plantings. Factors that affect the persistence of herbicides in the soil are classified as either degradation process or transfer process, or involve soil characteristics, soil biota, and the soil environment. We will see the factors affecting persistence. Biological decomposition. In that, soil microbes play important role. Soil is the mixture of inert or living material. Sand, silt, clay or organic matter make up the non-living fraction. The living fraction is composed of bacteria, fungi, algae, nematode, protozoa, worms, hundreds of other organisms. This living portion of the soil forces the turnover of nitrogen, phosphorus, sulfur, iron, and partially control the final fate of soil applied herbicides. The biological decomposition of herbicides include detoxification by the soil microorganism and the higher plants. Are you getting this? This is about the living portions and how they involve in this. The primary microorganism important for the herbicide decomposition are bacteria and fungi. Herbicides may remain active in the soil for a considerable time if soil is cold, dry, poorly aerated, and if other conditions are unfavorable to the organism, other microorganisms. The absorption of herbicides into the soil can result in a reduced ability of microorganism to break down it, as a herbicide is less readily available in the soil solution. Are you getting soil microbe? The various atoms that make up the herbicide also affect the microbial activity. The chemical containing halogens like chlorine, fluorine, bromine, iodine will decompose slowly. Another consideration in some fields where fumigation or sterilization has been used is that this process kills most of the microorganisms. And that's why the lack of microorganism results in no decomposition, stop decomposition of any herbicide residues in the soil until a microbial population can re-establish. Hence, we have to maintain the soil microbes in our soil for the herbicide decomposition. Soil pH is also a factor which affects the growth of microorganisms. In the general, bacteria actinomycetes are favored by the soil having a medium to high pH, and their activity is reduced below 4.5. Fungi tolerate all normal soil pH values. In the normal agriculture soil, fungi predominate at low pH. This is about the relation between the pH and the microorganism. Higher plant decomposition. Herbicides absorbed from the soil by higher plants are generally changed or metabolized. A small amount can remain in its original form and can be stored or extruded. This is about the biotic decomposition. Next is the how abiotic decomposition happens. Under that, chemical decomposition is the breakdown of herbicides by the chemical processes of the reaction in the absence of living organism. This may involve the chemical reactions like oxidation, reduction, hydrolysis. We take example atrazine will slowly hydrolyze in the presence of water, rendering it ineffective as a herbicide. Hydrolysis of sulfonyl urea herbicide in low pH or acidic soil. Different herbicides have the different chemical reaction. Accordingly, their decomposition changes. In the soil saturated with water, oxygen will likely become a limiting factor. No doubt there is no oxygen. Under such condition, anaerobic degradation of organic compounds can be expected. Trifluorine under standing water was completely degraded in 7 days at 70 degree Fahrenheit, and the non-articulate soil where only 20% had degraded at 38 degree Fahrenheit. Photo decomposition. See, this is also the helps in breakdown of herbicides. How? Photo, that is light. The process begins when herbicide molecule absorb the light energy, which causes excitation of its electron and may result in the breakage or formation of chemical bond. And most of the herbicides are white or nearly so, have peak light absorption in the ultraviolet range, that is 220 to 334 nanometer, where the yellow compound, yellow powder, such have absorption peaks at about 376. Okay, are you getting photo decomposition? Very easy. Volatilization is also acquainted by the high soil surface temperature, biological and chemical degradation, absorption by a few of the factors that should be considered in expressing and disappearance of herbicides from the site. Once they get disappearance from the soil. Shallow incorporation with the rotatory or hoe harrow is recommended to prevent the photo decomposition and volatilization if rainfall does not occur within 5 to 7 days of the herbicide application. Then, transfer process is important in determining what happens to the herbicides in the soil. See, adsorption by the soil colloid. This is also the important process. The interaction of herbicides with negatively charged soil colloids depends on the chemical nature of the herbicides. Positively charged herbicides like diquat and paraquat are held to the soil by the ionic bond, much like potassium and calcium are held. Okay. However, unlike the potassium and calcium, paraquat and diquat bound to the clays are not readily displaced through the ion exchange. These are displaced, but these are not displaced. Basic herbicides such as triazines can become cations in a low pH condition and absorb on the soil particles by changing from the net negative charge to the net positive charge. Thus, the activity of the triazines herbicides such as atrazine is greater in high pH soils than the acidic soils. Weak acids such as 2,4-D dicamba, then pyridine will lose hydrogen ion and go from to the net zero to net negative state, that is not readily adsorbed because they have the same negative charge as the soil particle. Okay, adsorption is process is related to the charge present on the soil particle and your herbicides applied. Accordingly, there is a transfer process related. However, the small amount may be retained by organic matter and the positively charged soil colloids such as iron and aluminium hydrous oxides. Small amount of neutral or non-ionic herbicides have no charge and little tendency to gain or lose the H plus ions. See, the soils having high organic matter require relatively large amount of most soil applied herbicides for the weed control. Then the soils which are high in the clay content require more soil applied herbicide than the sandy soils for the weed control. Then soils high in organic matter and the clay content have tendency to retain the herbicides for a long time than the sand are getting. The soil condition is very important. Leaching and movement to the soil. How the herbicides get leached out or moved out from the soil. Leaching is the downward movement of substance dissolved in water to the soil. Leaching may determine the herbicide effectiveness, may explain the selectivity or crop injury, or may account for the herbicides removed from the soil. Pre-emergence herbicides are frequently applied to the soil surfaces only. Rain or irrigation moves the chemical into the upper soil layer and weed seeds germinating in the presence of herbicides are get killed. Larger size seed crops such as corn, cotton, peanuts planted below the area of high herbicidal concentration may not be injured. In the addition to the protection offered by the depth, crop tolerance to the herbicides through the physiological process is also desirable. How the extent to which herbicide is leached is determined by the basis of adsorptive relationship between herbicides and the soil, solubility of herbicides in the water, and the amount of water passing downward through the soil. These three factors affect the leaching of the herbicides through the soil. Volatility and the surface runoff. The herbicides also get volatilized in this condition due to the lost into the atmosphere. Then toxic volatile gases may drift to the susceptible plants. Ester form of 2,4-diol volatile air and the vapors of fumes can causes injury to the susceptible crops such as cotton, tomatoes, grapes. Certain herbicides may move in the porous soil as a gas. Surface runoff. This is a basic concept. Removed by the higher plants. Then absorption and excretion by the plants and the animals. Herbicides are absorbed by the plant and the microorganisms can also extruded or discharged from inside the microorganism to the surrounding environment. The herbicides can be altered from the original form. Okay, generally this does not represent a significant percentage of amount of herbicides absorbed. Herbicide persisting 30 days or less may be used to control the weeds present at the time of treatment. Though those persisting for 30 to 90 days will protect the crop only during short period early growing season. This is generally adequate for many annual row crops that produce a dense canopy and thereby suppresses the weed growth through their shadings. Okay. Fate of herbicides. What is the fate of herbicides in the soil? See, both physical nature of herbicides, both physical and the structure of soil control the fate of herbicides. Most of the soil aggregates contain clay, organic matter, water, microorganism with which herbicides can interact. Once we apply, they can interact with. There are many components present in the soil. Overall, on complex soil structure are three possible phases in which organic herbicides can exist. The chemicals can occur in one, two, or all three phases of vapor, solid, liquid at any given time. There are four major attributes of the herbicides: water solubility, retention by the organic matter, vapor pressure, and the soil half-life. Water solubility. It is the reflection of polarity of chemical and is determined by the maximum amount of chemical that will dissolve in pure water at a specified temperature and the pH. In the general, more polar a chemical, the higher is its water solubility. Then retention by the organic matter. Herbicide absorption or adsorption is defined as retention of chemical or in the solid phase. Then potential to volatilize. Vapor pressure of a chemical is defined as pressure of gas that is in equilibrium with solid or liquid phase at a given temperature. It gives an indication of tendency of a chemical to escape from the soil surface as a gas. All the chemicals have a vapor pressure. Then soil half-life. Herbicide soil half-life is the integrated result of all herbicides loss pathways that act upon the parent herbicide when it is in the soil environment. The soil half-life is important because it affects the efficacy period, exposure to the environmentally important transport processes, and the potential carryover to the next crop. This is the fate of herbicides. Residual effect of herbicides and environmental toxicity. Adjuvants such as petroleum solvent, diesel fuel, then kerosene, methanol can highly toxic. In the addition, impurities resulting from the manufacturing processes can be more toxic than the active ingredient itself. See, the birds and the animals. A herbicide toxicity is described by its LD50, which is the dose received either orally, that is by mouth, or diarrheal, that is by skin, that kills half of the population of study of animals. The orally, this LD50 reported here were determined for the adult male rats, which is present in the soil to kill the rats. The dermal LD50 were determined for the rabbits. See, mouth dose and the skin dose. The LD50 is typically reported in the gram of herbicides per kilogram of the animal body weight. How it gives? This chemical is given gram of herbicide per kilogram of animal body weight. These are determined under varying circumstances. So, comparison between different herbicides may provide only a rough sense of their relative toxicities. Suppose dermal chemical value may be more meaningful to the herbicides applicator because they are more likely to exposure to the herbicide through their skin rather than by the oral injection. In any event, very few people, even among the applicator, are exposed herbicide doses as high as LD50. This is about the doses, how the this residual effect of herbicides by the on environmental toxicity through the animals or birds or mammals. Soil microbes herbicides has varying effect on the soil microbial population depending on the herbicide concentration and the microbial species present. Human toxicology. When the proper safety precautions we take, then there is a no any problem to human exposure of to the herbicides. Usually in natural areas should be minimized. We can minimize by taking the precautions. Properly fitted personal protection equipments and the well-planned emergency response procedures will minimize the exposure from the normal use as well as emergency speed situation. Also, the agricultural workers are often exposed to the herbicides when they are unintentionally re-enters a treated area too soon following treatment. People who mix and apply the herbicides are the greatest having the risk of exposure. The most common route of exposure is skin and by inhalation, that is lung. Accidental spills or splashing into the eyes is also possible with some compounds can result in several eye damage and the several even blindness. Okay, are you getting this is the this concept is about the human toxicology, how the toxic effects when affect on the people when they comes in contact with the herbicides. Next is the introduction to the selectivity of herbicides. Selectivity, that is very important. Selectivity is perhaps the most important concept of modern weed science. Because of this phenomenon, weeds can be controlled in the crops with the herbicides. Okay, particular weed having the particular name of herbicides. That's why it is made easy for us to kill the particular weed present in our crop. Herbicide selectivity to the particular crop is only within certain limits, and the limit is determined by the complex interaction between the plant, herbicides, and the environment. This selectivity is affected by this factor. Molecular fate and metabolism. The difference between herbicide metabolism in the weed and in the crop is one of the main mechanisms for the selectivity. The mechanism of metabolism varies significantly between different crop herbicide combinations, and thus a simple table showing how each herbicide class is metabolized not possible. The overall metabolism of herbicides in the plant can be divided into 4 phases. Phase first, it is a direct change in herbicide structure brought about by oxidation reduction hydrolysis reaction. This is first metabolism. That is, oxidation reaction of herbicides includes hydroxylation of aromatic rings, hydroxylation of alkyl group. In the phase 3 is the conjugation to the cell constituents such as glucose, then glutathione or amino acids. Many herbicides undergo phase first prior to the phase second. However, some herbicides can be directly conjugated to the no pre-oxidation, metribuzin and the 2,4-D. This is the overall metabolism of herbicides. And in third phase, conjugates are transported across the cell membrane into the vacuole or the cell wall. This is the assignment questions. You have to solve all these assignment questions in your assignment notebook. Okay. Today we will stop here. Okay, thank you. Today we will stop here.